Welcome to the notes for distance problems. Now, formula for distance, you have seen this one before in your life. Basically, the distance is equal to the rate times the time, okay? So if you are going 60 miles per hour, you are going a rate times a time, and that equals a distance. So that's what we're gonna do. So on this first one, on his way to Cleveland, Baker Mayfield traveled 50 miles per hour. So if he traveled 50 miles per hour, that's our rate for 6.5 hours. So this right here is our time. So if they say to you, how far did he travel? It is as straightforward as saying, all right, the distance is equal to the rate, 50, times the time, which is 6.5. Okay, so what is 50 times 6.5? That's where you get your, I'm going to see if I can do this on here, your calculator out, and you type in 50, and you just multiply by 6.5, and then you got yourself 325. So 325, don't forget your units. Distance, miles per hour, is going to lead us into miles traveled by Baker Mayfield, even though he will take the Browns to the Super Bowl someday. All right, so Molasses has been driving for 14 hours and has traveled 48 miles. How fast is he driving? So what's his rate? We don't know. What's his distance? Got it. And what's his time? So now what we do is use our formula. Distance equals rate times time. So the distance is now known. So 48 equals, the rate is unknown. We multiply that by the 14. So we divide both sides by the 14. And let's try to find out a rate here. So when I pick up my calculator and do 48 divided by 14, I get about 3.43. So the rate is equal to 3.43. And what's the rate? Well, this was miles, this was hours, so our rate is miles per hour. Man, that doesn't seem like it was very fast. 3 miles per hour? He's driving? That guy's like slow as molasses. All right, sorry, we will carry on here. I hope you enjoyed that. Now is where it gets a little bit tricky. All right, so what is going to happen now is we're going to talk about two different things going on at the same time. So reading this problem, Mr. Powell and Mr. Lemoyne decide to run a marathon. Mr. Powell gives Mr. Lemoyne a 1 hour head start because, let's be honest, I'm faster. If Mr. Lemoyne runs at a rate of 5 miles per hour and Mr. Powell runs at a rate of 6 miles per hour, how long is it since Mr. Powell started to catch Mr. Lemoyne? All right, so here's the deal. If we start here, if this is Powell and this is Lemoyne, what you need to understand is the little visual should help you set up these problems. Who's starting first? Well, if I give Mr. Lemoyne a 1 hour head start, that means go. He's running, and then at some point, I'm gonna start running. So I'm gonna start running. But if and this is hard for me to do on this program, but if I'm running faster, doesn't it make sense that eventually, at some point here, he's gonna keep going and I'm gonna keep going, but I'm running faster. At some point, I will catch him. Well, if I'm going 6 miles per hour and he's traveling 5 miles per hour, that makes sense. I'm going faster. So what you got to understand is at that point for this problem right here, we have both traveled a certain distance. This is distance Powell has traveled from here to here, and then this is distance Lemoyne has traveled from here to here. Well, what do you know? If it's a problem where we leave from the same spot and we catch the other person, that means that at some time, the distance Powell has run is the exact same as the distance Lemoyne has run. Well, now remember, way back up here, I'm going to take it up here so you see, everything goes back to the distance equaling the rate times the time. So you have to think about this in terms of rate of Mr. Powell times time of Mr. Powell, because that is the distance of Mr. Powell. It's really weird talking about myself in that voice. Okay, now we need to do rate Lemoyne times time Lemoyne. Now here's the deal. All these variables could super confuse you. I completely understand. But it all boils down to a pretty basic calculation in the end. It's just going to take us some time to get there, okay? So here's the deal. What I always like to do is I need to realize what we know and what we don't know. Like right now, out of rate and time of me, we know that I'm traveling 6 miles per hour. So I'm going to leave that right now. What do we know about Lemoyne? We know that he's traveling 5 miles per hour. The biggest thing is we don't know their times right now. We do know something about their times. And that's where we're going to go back to the problem here. And we're going to highlight, where does it say a 1 hour head start? So right now what you have to do is slow down and think, who's been on the road longer? Who's been on the road longer? Well, if you really slow down and think about it, Mr. Lemoyne has, because he had a head start, correct? I haven't been running as long because I'm running faster. So now, and this is the tricky part of the problem, what you have to do is you have to say, all right, let's make Mr. Powell's time T. Well, that means Mr. Lemoyne has actually not been on the road the same amount of time, but on the road 1 hour longer than Mr. Powell. So we got to relate it back to one variable. So the time for Powell now becomes T, and the time for Lemoyne becomes T plus 1. Again, that's a little tricky. It's going to take some time. This is the first day, but now look how simple this is. This is now an actually very easy equation to solve. When I distribute that 5 through, when I go through here, then I subtract 5t from both sides, I get time equal to 5. Now, what is 5? That's Mr. Powell's time. So to wrap up this together, how long does it take? It takes Mr. P 5 hours. Now, the question didn't ask this, but if it did, how long has Mr. Lemoyne been running for? He's been running for 6 hours, because 5 plus 1, which would be 6. All right? Okay, so now the next one is, very similar, except for you can see my visual here is about trains going in opposite directions. So let's read this one together. 2 trains leave the metro station at the same time, metro station, and travel in opposite directions. Okay? Opposite directions here. Their speeds are 60 miles per hour and 65 miles per hour. How long will it take them to be 500 miles apart? It all comes from the picture. So if we look at this, let's call this one right here the 60 miles per hour. And let's call this one the 65 miles per hour. So they're leaving at the same time. So what you got to understand is this one's actually going to be a little bit further if we draw this to scale, because it's going faster. This one's not going to be quite as far. If you don't understand that, make it 1 mile per hour and 65. You can clearly tell that this one will be further away. But here's the deal. At some point, according to the problem, they will be 500 miles apart. Well, now what do you go to? You go to basically, let me switch this up here. There's a distance by this train, and there's a distance by this train. Distance 1 and distance 2. Well, isn't it true that distance 1 plus distance 2 would actually be equal to 500 miles at some point? Well, all you need to know again is the rate of the first train times the time of the first train plus the rate of the second train times the time of the second train, and that's going to equal the 500. All right, good. Now, what do we got? Rate times time of train 1. Well, this is train 1, so the rate is 60. And here's the thing, the times are actually way easier than the last one because they left at the same time. So we have just t for time plus, what's the rate of the second train? 65. Exact same t because they've been traveling the same amount of time, and that equals 500. So when you just combine like terms here, I get 125t equals 500. Divide by 125. How many times does that go in there? So now we just pull out this calc if we need to. 500 divided by 125. Whoops. 500 divided by 1, 2. Why does it keep doing that? Sorry, hold on. 1, 2, 5 equals 4. All right, so we get our 4 there. So what is that? That is how long will it take them? It will take them 4 hours. Okay, what I want you to do right now is I want you to pause the video. That's my advice to you. I want you to try to figure out if you can do this problem without me, and then play the video and see if you got it right. Please do it. It's the honor system. Hit pause now. And I'm back. I hope you paused it. Okay, 2 cars start towards each other at the same time. Towards each other at the same time. If one car travels at 40 and the other at 55, so let's make this one go slower. That kind of makes sense to me. So 40 miles per hour, this one at 55 miles per hour. If they leave at the same time, I want you to know they're not going to meet in the middle. This guy's going faster. So they're going to meet, like, I'm exaggerating, but they're going to meet somewhere like right here. So distance by this car, distance by this car. But where did they start? The problem said they started 190 miles apart. So again, it's distance 1 plus distance 2 equal to 190. So then we do rate 1 times time 1 plus rate 2 times time 2 equals the 190. The rate of car 1 was 40. And then again, let me highlight it one more time for you. 2 cars start towards each other at the same time. So if that's ever happening, it actually makes the problem a lot easier because the t's are exactly the same for both of them. So 55t for this one, and we get our 190. So we got 95t equals 190. Divide both sides by 95 and you get 2. So the answer is 2 hours until they meet. Okay, hope this helps, and you can do your practice now. Just attempt them, do the best, but draw a picture, a diagram. It helps.